So, today's lesson, 4.4, we're talking about parallel lines. Essentially, what we're doing today is the exact same thing that we've been doing for the last few days. We're just adding on a little bit extra. Hopefully, you've seen the vocab word parallel before. If two lines are parallel, that means they never intersect. So, in a picture, they will look like two lines that go the same direction and they never intersect. When we are talking about equations of parallel lines, we need two things to be true in order for lines to be parallel. Those two things are that they must have the same slope and different y-intercepts. So if we think about the equation of a line, let's think about it in slope-intercept form, y equals mx plus b. That means that their m values for the slope are going to be the same, and their b values for y-intercept are going to be different. That's pretty much it. That's what we're going to be looking for in all of these equations. It's the same m value, different b values. So let's take a look at example 1. It says, determine if the following lines are parallel, explain why or why not. Essentially, what we need to do to figure this out is to get all of our equations into this form, y equals mx plus b. We've done this before. We're just going to solve for y for all of my equations. So in example 1, my first equation already solved for y. Perfect. Don't have to do anything extra. My second equation, I do need to solve for y. So I'm trying to get this y by itself. So I'll do it like I have done every other equation so far this year. I'm going to subtract 4x and I'm going to divide by negative 3. Keep in mind, if I'm dividing more than one thing on this right side, I have to make sure that I divide both pieces. So negative 4x divided by negative 3 is going to give me a positive 4/3 x. And 9 divided by negative 3 gives me negative 3. So far, so good. Our goal to get everything into y equals mx plus b. Now, I should be able to identify what is my slope in each of these lines and what is my y-intercept. So for my first line, my slope is 3/4. My y-intercept is 7. For my second line, my slope is 4/3. And my y-intercept is negative 3. I'm comparing my two slopes. Are these two lines parallel? No, the slopes are different. Any questions on number 1? Okay, look at number 2. I'm doing the same thing. Look at my second equation. It's already solved for y, so I don't have to do anything special to it. That first equation, how am I going to get y by itself? I need to divide both sides by 6. So this is y equals, remember there's like an imaginary 1 in front of this negative x, so it's negative 1 over 6x. 6 divided by 6 is 1. What do we think about these two equations? Are they parallel? Why? They have the same slopes. Look at their slopes, negative 1/6 and then negative 1/6. And what's the second thing that they need? James? Different y-intercepts. Okay, 1 is plus 1, 1 is plus 6. They are different, so we're good to go. Questions on that? Example 3, what do I need to do to this equation? My first equation looks good to go. It says y equals. What do I have to do to the second one? Yeah, Sarah.
Add 3.
Perfect. Y equals negative 2x plus 3. Y equals negative 2x plus 3. Are these two lines parallel?
No.
But they have the same slope. Why aren't they parallel? Because the y-intercepts are the same. If the slopes are the same and the y-intercepts are the same, that's just the same exact line written twice, right? That's the same exact equation 2 times, okay? So we can't say they're parallel. Any questions on these ones? Okay, that's what it looks like when you're trying to do it with 2 equations. How about we try to do it with 2 lines on a graph? If we take a look at these 2 lines, who thinks that these 2 lines are parallel? Anybody? We want to say maybe they look parallel. Remember our definition of parallel is that they don't intersect. Those 2 lines don't intersect. Maybe they will. I have to check. So I'm going to figure out. Do they have different y-intercepts? Can we say that already?
Yes.
We know they have different y-intercepts. Those y-intercepts are here and here. So I'm checking to see, do they have the same slope? If you remember, how do we calculate slope from a line that's on a graph? We're going to count the rise over the run. So take 2 good points, and I'm going to count from the left to the right. I'm going to go up 1, 2. That's my rise. And I go over 1, 2, 3, 4, 5. That's my run. The slope is 2 over 5. Same thing for line B. I'm going to take my 2 points. I'm going to count the rise. And I'm going to count the run. Are those the same?
No.
So are these lines parallel? All good? Flip it over. Are we confused about something? Do you have a question to ask me?
Oh, no, I'm just slow.
Okay, then we don't need to be talking unless you have a question to ask me. Example, what are we on? 5? This is the hard part. We can do equations of lines all day. But now I want to take a line and write another equation for something that's parallel to it, given that it passes through this point. We are going to follow the same 3 steps that we did when we were writing equations in the last section before your quiz. Do we remember what those 3 steps are?
No.
I should start every single problem by finding what? Slope. If my line is going to be parallel to one of these lines over here that I'm given, it shouldn't be too much work. I shouldn't have to plug in a formula. I should just be able to say, well, it has to be the same slope as the one that I'm given. So just take that slope and use it in our new equation. Once we have the slope, I start writing my equation of my line. What form do I use first? Sarah.
Point slope form.
Point slope form. Y minus y1 equals m times x minus x1. That is my point slope form. We always start in point slope form. And then if you can read it in my directions here, it says, write your final answer in slope intercept form. How do we get something from point slope form into slope intercept form? What are you pointing at? Yeah, how do we get something from point slope form into slope intercept form? Solve for? Three steps that I need to follow every single time. Can we do it? So let's take a look at this example. I want the equation of a line that passes through 12, 5, the point, and is parallel to y equals 2/3 x minus 1. So step 1 is to find the slope. If I want it to be parallel to this line, what should my slope be? 2/3, the exact same. Parallel lines have the same slope. Step 2. Now I'm going to write it in point slope form. Here, let me zoom out a little bit so we can see my point slope form. There it is. Y minus y1 equals m times x minus x1. I'm going to take my point from right here, x1, y1. I'm going to take the slope that I just found, y minus 5 equals 2/3 times x minus 12. Step 3. Now that I'm in point slope form, what do I do first? Cody. Solve for y. I'm going to distribute. Y minus 5 equals 2/3 x. What's 2/3 times negative 12? Negative 8 plus 5. Y equals 2/3 x minus 3. And that's it. Questions on that? We're going to do it one more time. Example 6. This time I'm passing through the point -3, -1, and it's parallel to 2y equals 4x plus 6. Step 1, what am I looking for? Slope. How am I going to find my slope? It is in the problem. Is that in a form right now where I can just say, oh, 4 is my slope? What do I have to do to this before I can just pull my slope out? Solve for y. Y equals 2x plus 3. So what slope do I need in my new equation? 2. Perfect. Step 2, write it in point slope form. Notice, my x1 and my y1 are negative, so I'm going to have double negatives here. Remember, double negatives become a plus sign. So y plus 1 equals m times x plus 3. Final step, what do I do? Oh, we're so close to being done. What do I do for my final step? Solve for y. Distribute. Y plus 1 equals 2x plus 6. Subtract 1 from both sides. Y equals 2x plus 5. And we're done. Questions on those problems? These 3 steps are the most important 3 steps. You do them when you write any equation in slope-intercept form, okay? Are we good there? We can do the application and then we can be done? On a coordinate grid, Johnson Street goes through the coordinates 2, 6, and 7, 10. University Ave passes through coordinates -2, 2, and 3, 8. Are these streets parallel? Explain. What do we need to know for things to be parallel? The number one thing for parallel, definition of parallel, is that what? Their slopes have to be the same. So let's find the slope between 2 points. How do I find the slope between 2 points? Let's start with Johnson Street. Johnson Street goes through these 2 coordinates. I have an equation that I need. What's the equation to find the slope? If I have 2 points. Yeah, Jacob.
y2 minus y1 over x2 minus x1.
Perfect. Remember, this is one of those formulas you need to have memorized. So I'm going to take my 2 points for Johnson Street. It helps me to label them sometimes so I don't get them mixed up. So now I'm going to do my slope equals 10 minus 6 over 7 minus 2 and simplify to 4/5. Same thing for university. I'm going to look at these 2 points right here. I'm going to use my formula. If it helps you, label them. X1, Y1, X2, Y2. 8 minus 2 over 3. Oh, here's a double negative. Minus negative 2. Simplify. 6 over 5. So answer my question. Are these streets parallel? Why not? Beautiful. Any questions?